Hi students, Mr. Epperson here. This is a video on mixtures and solutions. Some of the goals that we have for this lecture is to understand what a mixture is, the difference between a homogeneous and heterogeneous mixture, what a solvent is and a solute, and understanding the difference between concentrations of mixtures. Alright, well first the idea of what a mixture is. So a mixture is basically a combination of two or more substances, and it says in any proportion. What that means is when we look at something like lemonade, it doesn't really have any particular special formula to make lemonade. And what we mean by that is that it's not a chemical really, it's just putting two things together. In fact, that's one of the main points of a mixture, is that they're not really chemically combined at all, they just happen to be mixed. They're in the same place kind of at the same time. So we have mixtures of different states of matter in this example here, where we've got liquids and solids mixed in the same spot. That alone is a mixture. But additionally, we also have things like sugar to make lemonade, of course, you need that, and you need lemon juice, and you need, of course, water as well. So that idea of I don't know why I put them in two different spots here, but that is basically just the idea of what a mixture is. We're mixing things together. Now, there are two types of mixtures, and this is important that we get the difference between a what's called a heterogeneous mixture and a homogeneous mixture. The main idea is how evenly mixed they are, okay? Sorry, these are kind of running together, but here are the two different definitions, okay? That's for that one and that's for that one. So a heterogeneous mixture is one that is not evenly mixed. And what we mean by that is that this group up here is clearly distinct from this group down here. So there's two groups here. And of course, we'd imagine in a larger, box that we could draw here, there might be more than two groups. It might even be like 3 or 4 thousands of different groupings of things, but they're not evenly spread out. And that's the idea of a homogeneous mixture, is that it is actually evenly spread out, evenly mixed. We call that uniform. That's a term that we use for saying something is completely even. But if something is not evenly mixed, it's non-uniform. So let's see some examples to better understand types of homogeneous and heterogeneous mixtures. Homogeneous mixtures are when the particles, again, are uniformly or evenly distributed. So let's see some examples. It's best just to think of things in everyday life, because that's really the first line of defense, is looking at a mixture and seeing it with your eye and saying, which type is it? So soap is a homogeneous mixture, at least liquid soap is, because it basically is all the same. Wherever you look at the soap in the container, it's all going to be the same. And when you pump it out, you expect to have the same pump in the beginning as you do at the end of the soap jar, because it's evenly mixed. Jello is evenly mixed. Even though it's a solid, it is actually evenly mixed, and the sugar and the flavoring, each bite's going to be the same basic kind of mixture to taste, because it's evenly mixed. Coffee is also evenly mixed. Now, this is important that, of course, you'd had filtered the coffee well. If you don't filter your coffee well, you can have a bit of grit at the bottom, and that would actually not be a homogeneous mixture anymore. So that's a difference there. And then lastly, an example of Gatorade, right? You have a liquid that has sugar and the electrolytes and the water and everything mixed in there, but you expect every sip to have the same basic amount of stuff as any other sip that you'll take, because it's completely evenly mixed. Now, a heterogeneous mixture is one that's not uniformly distributed. And these are the ones that usually, if you buy it, it says shake well, right? And the idea of shaking up a mixture that you buy from the store, something that's like, maybe a creamer often, like oat milk. I always have to shake my oat milk in the morning when I add it to my coffee. Anything that requires shaking, especially things like, down here I have an example of oil and water, something like a salad dressing always should be shaken before you pour it, because essentially if you pour off an unshaken bottle of something that is heterogeneous, you're going to pour off something that has a different amount of stuff on top than it does on the bottom. And you want, for the best flavor, usually it be nice and evenly mixed. So heterogeneous is a non-uniform or not evenly mixed substance mixture. So we have examples like soup down here, sand grains with lots of different types of pebbles. If I scooped up one group of sand grains or pebbles, I'd look at another scoop and they'd all be sort of different. So there's not an even mixture of the types of sand grains there, or even just within a grain or within a stone or a rock, I could see that there's not an even mix of the different types of chemicals that the rock is made out of. There's more black and white here, and then there's some brown over here. And so I can see even the rock that's solid is heterogeneously mixed. And then the last example, kind of like the coffee and the grinds example, this is water with sand at the bottom, and that's a heterogeneous mixture. Actually, it's got a special name. It's called a suspension. The difference, though, between a mixture and what we're going to be really talking about today, which is solutions, is that in a mixture, you can just mix any two things together and you've got a mixture. But a special kind of mixture called a solution, okay, it is a type of mixture, but it's special because the solution is evenly mixed with dissolved substances in them. So salt and water mixed together are not just a mixture and not just a homogeneous mixture, though it's a solution because you've dissolved the substance into another substance. So we want to start talking about these terms here called a solute and a solvent. Those are the two parts of a solution. The solute, let's use the salt in the water example. I don't know why I've got these crazy colors here for salt and water, but I do. So when I put the salt into the water, I'm putting a solute into a solvent. Those are terms that you'll have to get to know and be used to using in class regularly, because we're going to talk about solute concentration. What we mean is the stuff that you put into the solvent to make the solution. And so if I'm putting salt into water to make salt water, the salt was dissolved, so it's the solvent, and it's the solute, and the water was the thing that dissolved the salt, so it's the solvent. And then that makes a solution. Okay, so the final result is a solution, which is solute plus solvent. Now let's put all that together and see if this makes sense now. We've got mixtures. The larger category of mixtures has homogeneous and heterogeneous mixtures as two main components. The homogeneous mixtures are made up of things that are solutions or things that are not solutions. And a solution always has a solute and a solvent. And that means that things that are not solutions, that are homogeneous mixtures, are do not really contain solutes and solvents. So let's talk a little bit about the difference in concentration then. Now that we've really got our head around solute and solvent and how solutions work, let's talk about dilute and concentrated. So a dilute solution and a concentrated solution. Let's use the example of the lemonade, okay? A dilute solution is going to be a small quantity of the solute per unit volume of solution. So a small quantity of solute, in this case, the solute could be one of two things in the lemonade. It could be the sugar that we added, or it could be the lemon juice, which is basically a mixture of a lot of things. The lemon juice itself is a mixture, but we could be focused on the acid in the mixture. And when acid gets added to water, it does spread out as it would like dissolve into the mixture. And so we'd say that a solution of lemonade really we'd be thinking about the solution of the acid as a solute dissolving into the water. And so let's think about that. The solute being the citric acid or the acid part of the water. You taste a very, very dilute solution of of lemonade, and it would be kind of bland. It wouldn't be very tart. It would be kind of weak, we might say. But if we tasted a more concentrated solution, this large quantity of solute would be high acid, and it would have quite the kick, right? We'd be putting, instead of maybe 1 or 2 lemons in a larger bit of lemonade, we'd be putting like 10 or 20 lemons and squeezing all those down to make lemonade. It'd be super sour, right? So that's the difference between concentrated and solute and dilute solutions, because it has to do with the quantity of, not the solvent, though if you increase the amount of solvent, you'll actually dilute your solution, but we really want to be focused on how much solute is dissolved in there, and we can actually measure that amount and compare it with another container of equal size to see if it's more concentrated or less concentrated. Lastly, super simple categorization here. If you've got a very, very dilute solution, or just a more dilute solution, you're going to have what's called an unsaturated solution. What that means is that you can actually put more solute, into that solvent. I can keep adding. For instance, I could keep adding sugar into my lemonade, put more sugar and more sugar. But if you've ever made lemonade, you know that eventually you can't add sugar forever. Eventually, the water can't take any more. And even though you keep trying to add it, it won't actually dissolve. So if I get to the point where I can't dissolve any more sugar into this water, then I've saturated my solution. And if I keep adding more, then I actually go into this super saturated definition where I've gotten so much sugar in there. There's some at the bottom. It's all floating around. It's overly saturated. In fact, if I left it there, because there's so much sugar in the water, it will actually start to grow crystals out of the sugar crystals out of the sugar that's already dissolved into the substance. So that's those 3 definitions between unsaturated, saturated, and what's called supersaturated. So did you learn the difference between a homogeneous and heterogeneous solution, mixture, the difference between a solute and a solvent within a solution, and the difference between dilute and concentrated solutions? I hope that was helpful.